So we're going to look at a 3 by 3 system of equations, and we're going to use the substitution method to solve this problem. So I've got three equations over here, and obviously we can see our variables are x, y, and z, and these equations are written in standard form, and we want to find out where these three equations intersect. So if you think about a 2 by 2 system, when you're trying to solve simultaneous equations in a 2 by 2 system, you're always looking at where they intersect. The same thing over here with a 3 by 3 system, is we're trying to see where these three equations meet. So normally you could just use your graphics calculator, and you could honestly just pop into your graphics calculator and go, if I go down to the equation part there, and if you just go F1 simultaneous and number of unknowns is 3, and you put this equation in this form, so if you see it's ax plus by plus cz equals d, and our equations are written in that form. So x is a coefficient of 1, and there's 2y, negative 2z, and it equals negative 15. The second equation is 2x plus 1y minus 5z equals negative 21. And then we've got 1x minus 4y plus 1z equals 18. And if we enter this, we get our three solutions. So x is equal to negative 1, y is negative 4, and z is 3. So what we could do is, now using the substitution method, solve this. We know our solution, so through the graphics calculator, but we want to show our working using the substitution method. So what I'll do is, I'll actually number these equations. So this is equation 1, this is equation 2, this is equation 3. And what I'll do is I'll rearrange equation 3 to make x the subject. So I can rewrite, so if I take equation 3 down here, just give myself a bit more space, so I can rewrite equation 3 as x equals 18 plus 4y minus z. So I just took all of this to the other side. Cool. And now what I'll do is I'll substitute this into equation 1 and equation 2, and I'll simplify it. Okay, so substituting into equation 1 first, we replace the x with 18. I'll do it in a different color. 18 plus 4y minus z plus 2y minus 2z equals negative 15. And I'll rearrange to make it y plus z equals a number. So we've got 4y plus 2y, which is equal to 6y. Negative z minus 2z is equal to negative 3z. And we've got negative 15 minus 18, so just taking this across to the other side, that becomes minus 33. And if I want, I can simplify this further. I can see 3 is a common factor, so I can take 3 out. So I'm left with 2y minus z equals negative 33. And if I divide both sides by 3, I'm just left with 2y minus z is equal to negative 11. So I'm going to highlight this equation over here because I'll use this. Now again, I'm going to substitute this equation over here into equation number 2. I'll do it in a different color again. So we've got 2, now replacing x with 18 plus 4y minus z, bracket 18 plus 4y minus z, and then up there we have plus y minus 5z plus y minus 5z is equal to negative 21. And again, let's simplify this. So we've got 36 plus 8y minus 2z plus y minus 5z equals negative 21. Again, we'll simplify this, writing it similar to the equation I highlighted earlier up here. So we're going to have 8y plus y, which is 9y. Negative 2z minus 5z is minus 7z. And we've got negative 21 minus 36, taking that 36 across to the other side. That becomes negative 57. And obviously I can't simplify that any further, so I'll leave it as it is. Now what I will do is, I'm going to now solve for these two equations over here. But before I do that, I'm going to rearrange this equation to make z the subject. So I can just write this as 2y plus 11 equals z. The reason why I chose z because it's the only variable on its own and it's easier to substitute it in after. And I'll substitute this over here into this equation. Now I'm going to try have just one variable and solve for the only variable. So again, so we've got 9y minus 7 multiplied by 2y plus 11. So replacing the z, that equals negative 57. Expand it all out. So we've got 9y minus 14y minus 77 equals negative 57. Now if you see, we've only got y now as our only variable. So now we can solve this. This will become a linear equation. We can solve for y. So we've got negative 5y is equal to positive 20. And again, if we divide both sides by negative 5, y is equal to negative 4. So we've got a solution now for y. Now we'll go backwards. So now I'll take this negative 4 over here, y equals negative 4, and substitute it in here to find out z. So again, I'll rewrite that equation. So remember it was 2y, or I just write it as z is equal to 2y plus 11. Substitute in the negative 4 for y. So z is equal to 2 multiplied by negative 4 plus 11. Z equals negative 8 plus 11. Therefore z equals positive 3. So we've got z now, and now all we need to find is x. And if you remember, we started off over here with this equation where we made x the subject. I'm just going to use the exact same equation and substitute in y and z. So we've got x, I'll do it in a different color. X is equal to 18 plus 4y minus z. Substitute in negative 4 for y and 3 for z. So we've got x is equal to 18 plus 4 multiplied by negative 4 minus 3. X is equal to 18 minus 16 minus 3. X is equal to 18 minus 19. Therefore, x is equal to negative 1. And we've got our three solutions. I'll write it over here. X is equal to negative 1. Y is equal to negative 4. And z is equal to 3. And this is the coordinate where the three equations intersect. Now we can write it like this as well. Negative 1, negative 4, and 3. We can write it like that, or we can write it in this form over here as well. So either one works, but that is how we solve a 3 by 3 system using the substitution method.